Bow your heads, please.
Dear God, thank you for today. Please help us just to learn everything that we can through this science today. In Jesus' name, pray. Amen.
Amen. Thank you. Now, we didn't do, we're going to do a review in a minute, but we didn't do experiment 2.3, and I thought maybe we would try it. So, let's read what it says. I'm on page 33. Running the experiment with air. Open the Ziploc. You'll find the bag with air. You want to fill the bag with air. I can read. Do this by holding the bag wide open, and then we're going to raise it up and bring it down. Put the thermometer in the bag and zip it closed, and then we're going to place it in a sunny window. So that's the first thing we're going to do. And I actually brought, it said that you needed heavier bags, so I brought freezer bags. So let's try this. So we're going to go like this a few times to get air in it. Woo! Okay, good. And slide one of these in here. Okay, so there's air in this bag. Now we're going to just leave it here for just a sec, because now we're going to make the carbon dioxide. So the second part, it says measure 1 teaspoon of baking soda and add it to the vinegar. All right, guys, I'm doing the vinegar like it said. Okay, we're making CO2, and the way we do that is baking soda and CO2 does a chemical reaction, and it releases carbon dioxide. So it says that we're going to do this. The contents of the bottle will begin to bubble. These bubbles will tell you the gas is forming. The gas is CO2. Wait 2 minutes. This will allow the CO2 to. Okay, so we're going to do it. We're going to do it once, and then 2 minutes later we're going to do it again. Woohoo! Well, maybe we won't do it again. Hey, you know what? I told you we were trying to blow the place up. That went a little better than planned, huh? Okay. So we're supposed to do that again. Yeah, I definitely need paper towels up here. Thank you. Because we're trying to make CO2. Here it goes again. Okay. So how are we supposed to get this in here? Open the Ziploc and press it flat to remove any air. Keep it handy. Add the baking soda to the vinegar and then quickly add this. Don't worry. Okay, so I'm going to do it one more time. So we want this flat, so there's no air in here except for the CO2 if it's possible. We are really making our little volcano thing go today, aren't we? We used up all the vinegar. Wondered when that would happen. Oh, here it comes. It's supposed to be collecting CO2. We'll see. Well, we'll see. Okay, now these two are supposed to go on a sunny window. All right, so right now they're both at 25. Yep. So we're going to put them outside, and we'll look at those in about 10 minutes. Yeah, so don't lock me out yet, okay? Thanks. Now, while we're making a mess, we'll just make another mess, because I want to show you. We had an experiment today, and wow, you guys should feel this. Hang on. It's an endothermic reaction, which means it's taking heat from the environment. Feel how cold it is. And that came right out of the room. Last week, we saw that oxygen is necessary for combustion. And we did our little experiment seeing that. But today, the chemistry students had a neat experiment with combustion. And it was cool enough that I want to show it to you. And I happen to have the stuff here because I just did it for them. Yeah, and it's kind of a messy one, too. So, and I'm a mess, so what the heck, right? Let's see. Okay, that's water. So we get water, a little bit of water, and then we get yeast, and we put, it said 1/4 teaspoon, and I guess I have a teaspoon here. If you mix the yeast in here, you don't really see anything but yucky water, right? Not a big deal. So then, so it's not reacting, basically. And that's because water's H2O, and peroxide, hydrogen peroxide is H2O2. It's got an extra oxygen. So what we're going to do is we're going to get the yeast to react the oxygen out, and it's going to make bubbles. And that's the oxygen that it's going to be releasing. So we're going to pour the yeast in here. And we're gonna mix it up a little. Here it goes. See it? No. You're supposed to let that go for a minute because you want it to get to the big bubbles. And then this is the fun part. And it'll make the... See how the bubbles are getting bigger? You see, no, but you see the bubbles are getting bigger? Everybody get to where you can see. The bubbles are bigger. Now watch this. This is so cool. So you're supposed to take a toothpick and light a toothpick. And you're supposed to burn it down a third of the way till you get an ember. See, it's a fiery ember, right? Watch. And I put it out, and I put it in the bubbles. Isn't that cool? Watch, watch. I just thought that was so neat. Woohoo! I mean, yeah. And I had a student ask what would happen if I dropped it in, so it flamed out. Isn't that cool? I just thought that was so neat. That you could put it out and it would just go right, it would flame right back up. Tried it with the match, it didn't work. And I'm thinking it's because the match doesn't give you the same fiery ember as the toothpick. Like here, let's try both and see. We'll do an auxiliary experiment. Here, let's try that. See, that doesn't come back. Do you see that? But this gives you an ember, and I think that's why it reflames. Isn't that cool? It's like fireworks. Woohoo! Sorry, I was having fun with that earlier. I'm like, wow, that is so cool. I've never done that experiment before. Anyway, we'll clean that up after. Okay, we are in Module 2. We are finishing it today so that after class you would study it and take your test for Module 2, which we'll grade at the beginning of next week's class. We're studying air. What did we call the water in the air?
Humidity.
Humidity, very good. And actually, on the next page, on page 26, it told us that the humidity makes you feel hot or cold, and when they put together the temperature with the with the humidity to tell you how it feels, they call it the heat index. And I heard on the radio this morning that our temperature would be 90 something, probably 92, but that the heat index was 101. They said it right on the radio this morning. So what that's saying is that the temperature is only about 92, but because the humidity is so high, it makes it feel like 101 degrees. It makes it feel hotter. So I was kind of tickled when I heard that this morning. Actually, I heard something on global warming yesterday, the newest stuff on that. So we'll talk about that in a minute. Yeah, that was the Lord helping me out, I'm telling you. So maybe to help me out, to help you out. How's that? Okay. If we look at the actual concentration of the water in the air, that was called absolute humidity. If we, are things going to blow up? No, we're okay? Okay. And if we looked at the percentage of water in the air compared to what it could hold, that was relative humidity. Which one was easier for us to use to actually tell what it's going to feel like? Absolute or relative?
Relative.
Relative, very good, because it tells you actually a percentage of how full the air is, and therefore you can know whether you're going to feel like this or whether it's going to feel okay because it's going to take some of the water off of your skin. Remember last week we saw that when water evaporates, it requires energy to go from dancing to bouncing off the walls, and therefore when the sweat actually evaporates, or when water evaporates, it's an energy requiring process, which means it removes the energy from our skin and makes us feel cooler. Yay! It's when it works, right? Yeah. Okay, so that's a good thing. And so the relative humidity helps us more because the absolute humidity, remember we said that the hotter it is, the more water the air can hold, and therefore if you actually don't know the temperature and how much air, water it can hold, then the absolute humidity doesn't give you enough information because normal people don't know that stuff, right? Okay, but what the relative humidity, if it's 50%, you know that the air still got 50%, that it can take up water, yes, and that'll make us feel better. Whereas if it's 85% humidity, we're going, oh, my hair is going to frizz and I'm going to sweat and it's going to sit there on my skin and that's not going to be fun, you know, unless you're into all that kind of stuff. So, okay, so we did that last week. Over on page 28, we saw that dry air is made up of a few components. What is dry air mostly made up of? What's the big one? Nitrogen. And everybody, what is the percentage of nitrogen?
78.
Very good, 78% nitrogen. And how much oxygen?
Very good. 21% oxygen. You have to know this for your test, and you really have to know it for the rest of the year. And then it's 1% what? Other. Very good. Okay. So 78% nitrogen, 21% oxygen, 1% other. You have to have that memorized. You have to know that. Okay. And that's what the dry air's mixture is. God put 78% nitrogen in there. Why? What was he worried about? Tell me something. There's a few ways you can go with this. Why did God put so much nitrogen into the air we breathe? Yes, George?
Because too much oxygen is bad for us.
Very good. If there's too much oxygen, like we saw with our experiment last week, and it flamed up really hard, our bodies would burn up, wouldn't they? There'd be more forest fires. There's other bad things that happen if you got too much. What's another good reason that God used it, Kiri?
It leaves the oxygen without creating another reaction.
Very good. It's a couch potato called an inert gas, which means it goes in, it goes out, it goes in, it goes out, but it doesn't affect anything. So it's the perfect thing to dilute the oxygen so that we don't burn up, or that we don't burn up the environment. Very good. That's where you were going, wasn't it, Caleb? Very good. Okay, good. You guys are doing really well. I'm proud of you. And we said that if the percentages even went up slightly on the oxygen, that we would have a huge increase in the forest fires and things like that. Yeah, it was, I don't have it memorized, but it was really, let's see. Increase the oxygen concentration by 10%, and you increase forest fires by seven times greater than what they are. That's huge if you think about it. And anyway, so, and then once again, you can burn up your bodies, etc. So it's not good. So then we got over on page 32 to carbon dioxide in the air. And the carbon dioxide is a greenhouse gas. And so is the greenhouse effect a good thing or a bad thing?
A good thing.
It's a good thing. Without the greenhouse effect, we would all be freezing on one side and burning up on the other. It literally grabs the sun's warming rays and keeps it in. This is the time when I always used to ask this question, and I'll do it here. How many of you have ever seen the cartoon when you were a kid, Frosty the Snowman? Remember Frosty the Snowman? We all saw it. That's great. We've got a common thing. Well, in Frosty the Snowman, do you remember, in case you haven't seen it, I just have to go through a little bit. And when, in Frosty the Snowman, she's taking him back to the North Pole, and it gets very, very cold outside, and he gets worried about her, so where does he stick her to get her warmed up? Do you remember? A greenhouse, that's right. Because even though it was cold outside, the greenhouse catches the sun's warming rays and holds them in, so it was warm in the greenhouse even though it was cold outside. Well, that's what the greenhouse effect does for planet Earth. Planet Earth is the same distance from the sun as the moon, which goes around us the whole time, but on the moon, if you're facing the sun, it's over 200 degrees Fahrenheit on the side facing the sun, and facing away from the sun, it's like negative 200 degrees plus Fahrenheit. And that's because there's no atmosphere. The atmosphere actually allows the sun's rays to be kept in. It's actually like a blanket around planet Earth. It holds the warming rays in. That's very important. I also want you to remember that CO2 is not the only greenhouse gas. Do you guys remember from your reading what another greenhouse gas was? That's a real common one? You're going to laugh. Water vapor. Water vapor is a greenhouse gas. How much water vapor is there on the planet? Oh, a lot, right? So we exhale it. Every time it gets warm outside, the water increases to go into the atmosphere. And so water vapor is also a greenhouse gas. Anyway, why is CO2 itself important that we just produced by bubbling all that craziness over and making a mess? Yes, Clay?
CO2 not only helps with the greenhouse effect, but it also helps with the plants.
Very good.
If there were no plants leads to no air leads to everything dies.
All right, so we need healthy plants, and the plants need the CO2 to actually do their photosynthesis thing, and then the plants exhale, or produce, we should say, they don't really exhale. They produce oxygen, and we eat the plants, and that is like the basic beginning of the food cycle, is that the plants take the sunlight and then turn it into food, and then things eat the plants, and then we eat the things or the plants. You get my drift. So it's very, very important, isn't it? CO2 not only keeps the sun's warming rays around the planet, but it also takes care of the plants. So would we be able to survive without CO2, class? No, we would not. We would all die. And then, not a nice thought. And then, although I don't mind the going to be with Jesus part, but the other part might not be fun. Okay, on page 35, it showed us inhaled air versus exhaled air. And we saw that when we inhale air, we got 78% nitrogen, 21% oxygen, 1% other. But when we exhale air, now we're also exhaling carbon dioxide and water vapor. Anytime you burn anything, you produce carbon dioxide and water vapor on planet Earth because the oxygen goes in. Well, I shouldn't say anything. Most things, when they're burnt on planet Earth, produce carbon dioxide and water vapor, including us. When we breathe, the reason we breathe and need oxygen is to burn glucose on a cellular level to make the little batteries. I think I mentioned that to you. Well, that's a form of combustion. We exhale carbon dioxide and water vapor. Did you guys know that? You knew that. Like if you exhale on something, like a mirror close or something, it'll make water droplets, right? So we exhale water vapor and carbon dioxide. But notice, we actually exhale 16% oxygen, and that's why CPR works. We talked about that last week, which was a big mystery to me. So I was really glad to find that out. Okay, let's see. I don't think we answered these questions on page 36 last week. Did we? I don't think so.
I think we did.
Did we?
Yeah.
Did we? Okay. It mentioned there above that there were two ways for carbon dioxide to get into the air around us, and that's through fires and living things which are actually burning on a cellular level. So all of it is really through combustion. But you read about another way that carbon dioxide can get into the air in the global warming article that you read. When the oceans get hot, what do? They release carbon dioxide into the air. Do you remember reading that? So when the temperature gets hot, the oceans release not only water vapor into the air, they release carbon dioxide into the air. And when it's cooler, they hold more water vapor and carbon dioxide in because they don't have the energy to escape from bouncing off the walls. Does that make sense? And so that's another way that carbon dioxide can be added to the atmosphere is through just general warming of the temperature and then, the carbon dioxide being released into the atmosphere. But once again, your book doesn't mention that. That's just something we know from the extra reading we did. Okay. I don't think we did these in class. Let me just run through them real quickly. 2.5, we know that if the carbon dioxide concentration were too low, plants would starve. Conversely, experiments indicate that many plants actually flourish when the concentration of carbon dioxide in their vicinity increases. How can this fact help explain why some experiments indicate that houseplants tend to grow better when their caretakers talk to them? They're looking for there that if you're talking to it, you're breathing carbon dioxide on it, so it should be happier. I personally think the plants do like to be talked to, but that's just me. I talk to everything, so. I'm so glad I'm a Christian because then I can talk to the Lord and it makes more sense. 2.6, we know that our bodies do not use the nitrogen we inhale. Nevertheless, in figure 2.5, notice that the percentage of nitrogen in exhaled air is lower than the percentage of nitrogen in inhaled air. If our bodies do not use nitrogen in any way, why does that percentage decrease? I think we did do that one because I showed you guys that when you add more pieces to the percentage pie, then all of the pieces have to get a little smaller. And so that's why. Okay, then we got to global warming. I just want to see if our experiments worked. Hang on. Let's see what we got. It's not exactly a sunny window. Did anybody try that one at home? Yep. Did you? Is that the one you wrote up? Oh. And what were your temperature differences?
It wasn't by much. It was only like
a degree or so?
3, something like that.
Oh, well, 3 degrees, that's at least you saw a change.
I think that was Celsius. So.
That's fine.
Okay.
Yeah, that's great. That's actually even more if it's a 3 degree Celsius change. So that's fine. Good. Ours didn't work because you had it in a sunny place, didn't you?
Yes, ma'am.
Yeah, see, ours didn't work because we don't have a sunny window. Well, we tried, didn't we? Did you make an explosion when you made your CO2? You too? Yeah. I wonder why mine went so crazy. Maybe I put too much in.
I don't know.
I don't either. Anyway, okay. Well, now you know how to make a little explosion when you go home. Just baking soda and vinegar. I think that's the explosion they do in most volcano experiments. Yeah. So you could always put like red food coloring in it and make it look really interesting.
For the very first time this experiment worked. This one showed, after being out in the sun, a temperature of about 40 degrees Celsius, but this one showed a temperature of about 44 degrees Celsius, which is, wow, much higher. And it's interesting, I was telling the students that I actually put the carbon dioxide in here, but because I didn't have enough bags, I scavenged this bag from something else, and it has a lot of moisture in the bag, and the students noticed that. When you look at this bag, here, I'm going to put it over here so you can see the moisture in the bag, and whereas the one with the carbon dioxide in it, you don't see the moisture in the bag. Well, I really think that remember, CO2 is a greenhouse gas, but water vapor is a more important greenhouse gas. And I think that's why this one actually showed the higher temperature, is because it had the moisture in it, which out in the sun really made the temperature go up. And they were side by side on the hood of my car in the sun, right next to each other. So they should have said the same temperature. But the greenhouse gases, the water vapor, actually caused this one to be warmer. Just wanted to show you that because it was the first time it ever worked. Praise the Lord.
Okay, let's do global warming. Global warming, first let me ask you, is it happening? No, not unless you consider 1 degree Celsius global warming, right? And that's what we're constantly hearing is about how things are heating up. Now, I told you, I heard this on the news. I heard just yesterday that there were 4 studies just completed on global warming, and that they said nobody can see any changes to the sea levels due to global warming. That there have been studies looking at it, trying to find changes in that have to do with sea level, and nobody can find any changes at all. Even the people that really want there to be changes can't find any. So I thought that was interesting because that's like 4 of the newest studies on that. Global warming is a political issue. It really, really is. And let me ask you this, is CO2 in the atmosphere on the increase? CO2, carbon dioxide. Look at your graphs on page 37. And the top graph is the carbon dioxide levels and average global temperatures. The top graph, on the left-hand side of the graph, you have the carbon dioxide. So here, you have the concentration of carbon dioxide in the atmosphere. And along here, you have time. So if this goes this way, and this is increasing, is the carbon dioxide in the Earth's atmosphere increasing over time? Yes, because it's going up. That means the concentration is going up as it goes along in time. That's how you read that, okay? So it is going up because remember, carbon dioxide gets into the Earth's atmosphere through burning things, through respirating, things breathing, and through the oceans getting heated up. But we'll just count that out for just a minute. We have more people today than we had in the past. Therefore, there's more people respirating, producing CO2. We also have more people burning things. And even when we turn on the light, we're burning something. When we turn on our cars, we're burning something. And when we use our cell phones, that's batteries, we're burning something. Okay, so we use a lot more of that stuff, and since the Industrial Revolution, there is a lot more burning and there's a lot more people, so there's more carbon dioxide in the Earth's atmosphere. But that doesn't inherently turn around and say, well, because the carbon dioxide is going up, so is the temperature, because that's not what we see. If you look right below that, you see the graph, and on the left-hand side, I want you to notice on the left-hand side, all the way at the bottom, let's do it. You have a -1. And then all the way at the top, you have a 0.6 with a 0 right here in the middle somewhere. I want you to notice it doesn't even go from -1 to +1. It's not even 2 degrees, is it? And this is over time, and all you see is this line, right? So do we actually see a temperature increase? Not really. And I want you to notice on that dotted line, to the left of that dotted line, they had to take the temperatures from the ground, which means 72% of the planet wasn't being taken into consideration because the oceans cover almost 3/4 of the planet. And on the right-hand side, you've got actual satellite data. And so at that point, you actually do have whole Earth information, and it's still not just increasing, is it? Is it? No, it's not. So we don't seem to see global warming happening. And in the book, it actually talks about that there's a lot of different studies going on and that people really can't decide if it's true or not. Now, in the article that you read, that's what I'm going for here. In the article that you read, it talked about the 5 claims of global warming. One of them is global warming happening. What do you think? Do you consider a 1.7 degree change global warming? No, most of us wouldn't. So most people would say no, even though we're told global warming is happening all the time. Most people would say no. I had a past student the other day tell me that her mom told me that she was in a 4-H thing and the 4-H naturalist was talking about global warming, and the kid raised her hand and she goes, I don't think global warming is really happening. And the naturalist was very good with her, and she goes, well, why would you say that? So she started to go through some of the stuff she learned in physical science. I was so proud of her. So was her mom. And some other kids in the class had, they just took the Apologia, and they had some good points that they made with the lady, and she said she was going to look into it. So I thought that was really good. So you guys can have a real effect when you politely share information with people. Anyway, so it's probably not really happening. And then, let's see, the next part, and like I already mentioned, the CO2 itself is on the increase, but the temperature is not increasing. And they say that that's partly because we're not exactly sure how it all plays out as far as there could be other gases being formed that while the CO2 might grab the heat, these other gases might actually reflect the heat back into outer space. We're just really not sure. But we don't see the temperature increasing even though the CO2 is on the increase. It wasn't in this article, but there's also, was it in your article? Because it wasn't in the one I read, and I'm just checking. The pros and cons of global warming. Did you get to read that? No, this was just on these 5 things. These same people that wrote this, and this is from some creationists, it's from a creationist perspective, said global warming, even if it did occur, might not be such a bad thing, because they went through and explained, as a Christian, we're supposed to look at people being more important than animals or anything else, correct? Because people are made in the image of God. And so if global warming was occurring, actually, that would mean longer growing seasons in a lot of places, so that we could produce more food and we could feed more starving people. It would mean more jobs for a lot more people. There were all these reasons where global warming was actually a very positive thing for people in general if it was happening. And I thought, that's a really good point. And it was on Janet Parshall's show on Moody Bible Institute's program that I heard it yesterday about the thing. And she made another point, which I've heard before. In Africa, there are people that could get electric power that are not allowed to have electric power because the environmentalists won't allow it, because they say there's some owl or some critter in that area, so they won't allow them to run electricity into those areas. And those families are burning animal dung to cook over. That means animal doo-doo, dried animal doo-doo. And the problem is there's carcinogens and things in the animal dung, and it makes them have respiratory issues, and it kills them eventually, especially the children. So basically what we're hearing is that the environmentalists, not surprisingly, are more concerned about not letting these people have electricity so that they can save whatever animal they're worried about, and killing the people. And this is kind of where we're going right now in our world. And that shouldn't be. As Christians, we should not allow that. Now, I want you to know it wouldn't kill off the animals that they're worried about. They would just have to share with the electricity coming through that area. But the environmentalists make it like, well, you have to choose between the people and this, and they choose the animals. They don't choose the people. As Christians, can we get away with that? No. I won't say too much, but I was in church last week and said something about there's a saltwater crocodile in my parents' canal in the Keys. Did you guys know we have saltwater crocodiles down here? We're the only place on the planet that has alligators and crocodiles. Oh, aren't we special? Anyway, and I'm so happy. I don't like critters that eat people. I just have a problem with that. And I don't think critters that eat people should be around people. So I'm in church and I said something to the man behind me about there's an 8-foot saltwater crocodile in my parents' canal, and that I thought maybe that we should get the freshwater commissioner and people to come get the crocodile. And he goes, oh no. He goes, they're all over the place down here. You just leave them alone. And I go, but they eat people. And he goes, well, we live where they live. And I'm thinking, this guy's a Christian. He's sitting in church. And I was raised by a dad. We hunt, we fish. He's a very much a conservationist, because people that hunt and fish want to keep the environment healthy so that they have things to hunt and fish. I know a lot of people don't understand that, but that is how I was raised. He's part Cherokee, and he's very funny about all that stuff, okay? But I'm looking at this guy in church going, crocodiles eat people. I don't think they should be allowed to be in the same place where the people are. I think they need to remove them and put them back in, Everglades National Park or something like that. And he goes, no, they live here. We decided to live where they live, so we need to get over it. I'm sorry, I have a problem with that attitude as a Christian. That's a very politically correct attitude. And I'm going to tell you why I said that. And I said this to the guy before the service started. You know that my old home is in Big Cypress Swamp. They're having bear issues. We've protected the bears long enough now that there's so many bears that they're chasing people. And there's bears biting people and stuff like that. So in Ave Maria, which is a Catholic community out where I used to live, very nice Catholic community. My kids are actually building a home there right now. 2 of my kids. They've had a problem with these bears chasing the children and trying to bite the children. Now, I don't know about you, but I said to this guy, I said, if a bear's chasing my kids, it's going to be a dead bear, because I'm going to shoot the bear. I don't care who says anything. If there's a crocodile, because the guy said, well, a crocodile was up in one guy's lawn trying to get his kid, and when he shot it, he got in trouble. And I'm going, that's not right. I said, when an animal threatens your family, we should have every right to kill the animal. That's biblical, isn't it? Okay? You got to protect your kids. You got to protect people. And this bear that was in Ave Maria chasing these kids, every time they'd call to get the people to come out and get them, the FWC, they call it Florida Wild Commission, they'd call them, they'd come out and say, no, you live where the bear lives, leave them alone. Now, once again, I'm not a nice person. That's why I have to repent a lot. I would have had a lot of words with that person, because my kids are more important than that bear, okay? But do you know what ended up happening? The guy went out there and the bear chased him down and pinned him down, and the guy ended up shooting it to protect himself. Well, when he killed the bear, it was okay. But when those other people were trying to protect their kids, it wasn't okay. I have a problem with that. And I told the guy in church that, and he just looked at me, and then the service started, and I'm like, I'm sorry, I'm all about protecting things, but where people live, people eating animals need to not live. And we should have the intelligence to remove the people eating animals and put them someplace where it's still more natural. Because you're not going to let them just sit there and eat you, are you? I don't want them to eat my dog either. Who's kidding? I mean, really, Anyway, okay. So, but that's part of this whole politically correct thing. I just want you to understand that. That's this idea, well, we'll let people burn dung and breathe in all these bad things and die because we're going to protect some animal. It's kind of right along the same lines, isn't it? And we have to be careful of what we believe. Okay, we have to really take it through a biblical worldview and try to figure that out. So, sorry about that. Okay, let's see. The next question was, are we causing global warming? Yes, Amanda.
It was I had something to say about what you're talking
Yes.
about. What you're talking about kind of reminds me about Harambe, the gorilla who child. It kind of reminds me of that situation.
Yeah, everybody might not know what you're talking about, but wasn't that a child fell in with the gorilla, and the gorilla...
I think the gorilla was trying to protect it.
Yeah.
People at the zoo were thinking that he was trying to kill it.
Sure.
Shot.
Sure. But they do need to protect the child. It's just sad that I think the parents are the ones that should be in trouble on that one. How did that child get in there? Do you see what I'm saying? I immediately go back to the parents, because you can't always be in control, but if you've got your children where you're in a zoo or something, somebody should be holding on to their hands, Yes.
I think it's actually the fault of both the parents and the zoo since they didn't have a very safe.
Oh, was it not a real safe environment? I don't know the
They didn't wanna
details.
get in there.
Yeah, I don't know. That's
He
a
was
good,
like 3 years old, so.
yeah, that's a good question. How was the child able to get in there so easily? That's a really good question. So maybe there was fault on a few people's part. And I know some kids are really hard to hang on to. My second daughter was like that. Yeah. She told me, as now she's grown, she goes, "You used to put a harness and a leash on me." And she was really offended. And I looked at her, I go, "Wait till you have a kid that you can't hang on to." I said, "And you were my baby girl, and I didn't want you to disappear." You know, and she was a little blonde-haired, blue-eyed, little cute little girl, and she would disappear. I lost her at one of those Indian things once where you go out and they do the Indian reservations, and you know, there's people everywhere, there's food everywhere. It's kind of like a carnival situation, but it's like a reenactment type of thing. She was gone, and she's like 3 or 4 years old. My mother and I were freaking out. And then she comes walking up, and it was so funny. She looks at us and she goes, "Don't you ever do that again." Because apparently she was scared too, because there were so many people around. After that, I put a harness and a leash on her, and she did not like that. But now she's pregnant, so I'm waiting to see what happens. Because when your baby starts to walk away from you, that's funny, because my youngest one, if I took her to the mall, the other two I could hide. If I was trying to teach them a lesson, Mom's going to appreciate this, I would hide from them if they were wandering off, and I would watch them so that they would get scared. My third one didn't care. I could hide, and she would leave. She was just, didn't care. And I'm thinking, man, so that never worked. It backfired totally on me on that one. So you got to figure out which works with these kids. It's funny. Your mom did that to you too, I can tell by the smile.
Yeah, my mom did that to my brother. He was babysitting us, and she said, "Don't fall asleep," and he fell asleep. So when she came home, she hit us and woke him up and started screaming at him.
Oh, that would effectively do that. Yes, okay. See, moms have to use all those techniques. So do dads. I just want you to know. All right.